Okay. So, sir, should we start now, or we'll have to wait for some maybe 1 or 2 minutes?
Yes, we can start. I think already there are near about 30 participants.
Yes. So, if you permit, we'll start.
Yes, yes, we'll start.
Okay. Okay. So, good afternoon, all the participants, and I welcome you all to this first session of third day of this workshop. That is the fourth edition of 1 week national workshop on emerging tools and technologies in research. So in fact, this is the fourth day of the program. This program is basically targeted on and focuses on I mean the most of the benefit of the most of the participants, like social sciences, arts, all of the students, all of the participants of different background will be benefited from this workshop. I mean, from this talk as well as the next talk. So this talk would be based on R programming and how to analyze the data and work with R programming. So, sir, welcome you to this session and thank you very much for accepting our invitation. So, let me introduce our speaker for this session. This session will be taken care by Dr. Utpal Pal. He is currently working as a system analyst at Tripura University. He had been our esteemed faculty and beloved faculty in the Department of Information Technology of Tripura University, and he has an working experience in this department over 10 years. Basically, he has the expertise and the endorsement on machine learning, calculus, classification models, and he has completed his PhD recently in 2021, and he has done the extremely well in R programming and published a handsome number of high quality journals as well as conferences. So, sir, I hope the student would be benefited, especially in this R programming and how to work with and how to start with. With this brief introduction, I'd like to hand over the session to you. Sir, please, you can start. Hello, Utpal sir. Hello, Utpal sir. Utpal sir, am I audible to you?
Hello.
Yes, sir, I'm here. You can start your presentation.
Shall I start?
Yes, yes, sure. You can start, sir, please.
Hello.
Yes, it is visible. Can you please present it in slideshow mode? Yes, now it's okay.
Okay. Good afternoon, everyone. Uh, First of all, I would like to thank Department of IT, all the faculty members of Department of IT, especially uh, Dr. Alok and Jayanto sir and the HOD of the department and all other faculty members. So today my uh, session is about data analysis using R. So these are the contents I'm going to speak today. First, the data and data analysis and why the R is important. Basic language constructs, that is the basic building blocks of the programming language R. I'll discuss about that. And then how to start working in R and RStudio, how to load the data set into the program. Then I'll show one model building where I'll show the different data cleaning operations like missing value completion, feature reduction, then model building, testing and prediction. So if I divide the topic is actually data, analysis of data, and analysis of data using R. So first of all, what is data? Data are values of qualitative and quantitative variables belonging to set of items. Now, set of item means population, the set of objects you are interested in. And data analysis, it is a process of inspecting, cleansing, transforming, and modeling data with the goal of discovering new information, finding new insight, making decisions, or giving conclusions or prediction. And data analysis has various steps. So this is a typical data analysis flow. To start, the data analysis process starts with importing the data. So when whatever format the data is, we have to import into the system. Then prepare the data, clean the data, because in real life data is not clean. So we need to clean the data. This is called data pre-processing. After that, fit the model. It can be a statistical model or um, any model, any machine learning model or whatever model we want to fit. Then after that, evaluating the model. That means if there is any, if the model is not up to the mark, and if the reason is for cleaning or for pre-processing, then we have to go back and clean the data again and feed the model once again. Now, when we are satisfied, then validation of the model. So this is cross-validation. Now, once cross-validation is over, if we are not satisfied with the validated model, we can go back and fit the model once again. Once we are satisfied, we'll come to evaluate the model and prediction. Evaluation and prediction. At this stage, we have new data at our hand, and we will predict for new data, and finally produce the report. So this is a typical model of data analysis steps. Now, so data analysis using R programming language. So first of all, let me tell a little bit about the history of R. R is an implementation of S programming language, and S was created by John Chambers in 1976. In 1991, Ross Yaka and Robert Gentleman at the University of Auckland, New Zealand, wrote R, which is an implementation of the S language. It was named after the first name of the two R authors, that is Ross and Robert. In 1995, Martin convinced Ross and Robert to make R free and open source software under the GPL license. And the first official release came in 1995. The R core team was formed in 1997. Now, why to learn R? Why it is important? The first thing is that R is an open source language, and it is maintained by a community of active users and can you can avail R for free. And one can modify various functions in R and make it his own package. R is easy to extend through functions and extensions, and its community is noted for contributing packages. Since R is issued under the GPL license, there is no restriction on its usage and redistribution. R is the most popular language for data analysis and data science, and R was mostly used in, even though it was mostly used among the academicians, but with the emergence of data science, the need for R in industries has become evident. It is the most suitable language for performing statistical operations, and it has a robust collection of packages like ggplot, plotly, and many other packages like that. And R implements various statistical and graphical techniques, including linear and nonlinear modeling, classical statistical tests, spatial and time series analysis, classification, clustering, and so on. For computationally intensive tasks, C, C++, and Fortran code can be linked and called at runtime. Advanced users can write C, C++, Java, and .NET code to manipulate R objects directly. R is highly extensible through the use of packages for specific functions and specific applications. And due to its heritage, R has stronger object-oriented programming facilities than most of these statistical computing languages. So these are some of the reasons that why we should go for R. Now I'll start some basic concepts from R, the basic language constructs like variable, then data type, and control statements. And slowly I'll go to R and RStudio and we'll write some programs. So let us see some basic concepts. Variables. So what is a variable? A variable is something which can hold values. So a variable is a named storage that our program can manipulate. A variable in R can store characters, numbers, vectors, objects, etc. A variable name starts in R. Variable name starts with a letter or the dot not followed by number. So here are some examples of a valid R variable. For example, here we can start with any character and we can give underscore. And see here, if we give any percentage symbol, then it is invalid. So these are some examples for valid and invalid variable names. Data type is a very important part in any language. So in R, a variable itself is not declared of any data type. That means we do not declare any type of the variable. Rather, it gets the data type of the R object assigned to it. That means whatever value we assign to the variable, that type is automatically declared by R. So R is called a dynamically typed language. Okay, and R supports the following data types apart from the basic types like numeric, integer, logical, complex, and characters are called primitive types. Apart from these primitive types, R supports vector, lists, matrices, arrays, factors, and data frames. Now, vector is a very important data type in R. Most basic R data object contains objects of same type. That is, vector contains data of same type, and we can create a vector in different way. Like using here I've shown creating a vector using column. So as you can see here, 5 column 13 means it will contain value starting from 5 up to 13, incremented by 1. And we can create a vector of floating type data also, or decimal value also. Here we are assigning 6.6 to 12.6. That means these are the output. This is the code and this is the output. So you can see here 6.6, 7.6 like that up to 12.6. So you can create vector like this. Another way of creating a vector is using the function seq, that is sequence. So here a vector is created with the function sequence, and starting at 5 and up to 9 by 0.4. That means every time the increment will be done by 0.4 will be added to each number. So this is the output. First is 5, then 5.4, 5.8, like that up to 9. One more way to create a vector is using the C function, which is a concatenate function. So here we are creating a vector of 4 objects. The first one is a character, second one is character, then a number, and then logical value true. Now accessing the vector elements, these are important because when we write programs, we have to be very clear with the basic language constructs, what is data, what is variable, and what are the different things. So how to access the elements of a vector. So here we created a vector. C, these are all the strings, and if we want to type, or if we want to access the second, third, and the sixth element of this vector. Now here this arrow represents what? Actually we are assigning this list, this vector to the variable t. Okay, so now the value is stored at t, and we want to access the second, that means this Monday, third means Tuesday, and sixth means Friday. So these are 3 values we want to access. For these we can write like this: t of c and 2, 3, 4. So when we print it, we get Monday, Tuesday, and Friday. Now how to manipulate a vector? Vector manipulation. Now suppose we have 2 vectors. One is v1 and another is v2. Okay. Now if we want to add these 2 vectors element by element, then we can simply write v1 plus v2. Okay, and the result will be stored at this variable. The variable name is add.result, and we can print it like this. And if you want, you can also sort the elements of the vector. Suppose we have a set of numbers. Now if you want to sort it, then simply use a sort function, and within bracket you put the name of the variable, the name of the vector. So it will automatically sort, and you can print the result. And you can sort a vector in the reverse order also. Next important variable is list. Now list is a collection of different types. Okay, so in a vector you can store data of same type, but in a list you can store data of different types. Suppose you want to store the student's information. The student has name, then they have marks, grade. So we have different types of data. Character we have numeric value. So such collections can be formed using list. Now how to create a list? Simple. It is list, and within bracket you have to put all the data. So here we have created a list using 2 strings, red, green, and this is C of 21, 32, and 11. That means we are creating a vector here. So a vector itself is a member of this list. And then true is a logical value. So we have here character, a vector, and a logical value within this list, and assigning this list to this variable list underscore data. Now when we print it, we get this information. Okay, so red, green, and the vector, we have 3 elements in this vector, and this true. So we have totally 4 values. 2 are strings, 1 is logical value, and another is vector, numeric vector. Now one more thing, what are these brackets? That I'll talk when I'll go to the lab and when I'll start writing the programs. Now in list, you can name the list. List items can be given names. For example, here we have a list, we have one vector, character vector, we have one matrix, and the matrix is 2 rows. So this list, the values of this list can be given names. For example, we have created another vector here, two strings, and we are assigning this name to this list. Okay, to this list. Now, when you print it, you get the first quarter, that is the name of the first element of the list, and this is the name of the second element of the list. And here accessing the list, how to access. So as like name of the list, and within square bracket, if you want to access the first element, then put 1. If you want to access the second element, then you have to put 2. So here we are accessing the first element to list of 1. That means it will print the first element of the list. What is the first element? This is the first element. Jan, Feb, and March. This is the first element. So we have got here in the output, we have got first element. And similarly, you can do various operations on list, like merging the list. If you want to merge two lists, then simply you can combine using the C function. So in the C function, here we are mentioning list1, list2. So these are the two lists which are combining using the C function. Okay, so two lists are combined. Next important data type is matrices. So elements are arranged in two-dimensional rectangular layout. Okay, for example, we can create a matrix. So in mathematics, we use a lot of matrices. So here we are creating a matrix of 4 rows and 3 columns. Okay, so and we start with the number 3 up to 14, and n row equals to 4. That means 4 rows will be there in the resultant matrix, and by row equals to true. That means the elements will be arranged row by row. So we are starting with 3. That means 3, 4, 5, and 6, 7, 8, 9, 10, 11, 12, 13, 14. So we can create matrices row wise as well as column wise. Now we can, if we require, then we can name the rows and column also. So here I have created row names and column names. So the column names are actually these are created in vectors. So the first vector contains all the row names, second vector contains all the column names. Now so here see here the matrix is formed, and we can assign the column names also. Using, and the syntax is this: matrix, the elements of the matrix, and row, that means 4 rows, and it is by row wise, and as part the, just a minute, I'm sorry, it's called. Sorry. Okay, so and we are giving here dimensions. That means list, row names and column names. So dimension names. So in dimension names, we are giving the rows and columns. Next, how to access the matrix elements. To access the matrix elements, we are using the brackets. So here P is the matrix. Okay, and we want to access the third. Suppose we want to access the third row, column and first row. So for this we are giving 1, 3, and accessing the second column and fourth row. So for this we are giving P of 4, 2. Like that we can access different elements of the matrix. Here is the output. And the matrix computations, we can perform matrix multiplication, matrix addition, subtraction, and these are the functions for this. Matrix multiplication and division. Next is factor. Factors are the data objects which are used to categorize the data and store it as levels. Now, for example, here we have a vector which has east, west, north, and like some strings. Now, if you want to know what are the different levels of data we have in this, So for this, we can create a factor for this, and if we print it, we get there, because here we can see east, west, and north. We have three types of east, west, and north. So we have three types of uh, strings. So what are the different categories of data we have? To know that, we can use factors. Okay. So next we have data frame. Now, data frames are very useful. Uh, for example, if you are to create a student table, so in a student table we have a student's name, their marks, so different types of data we have, and that should be in a tabular format. So tabular data we can create using data frames. So to create a data frame, we have this function data.frame, and you put whatever value you want. See, here we have a vector, here we have another vector of strings, here we have another vector of real numbers. So we have three types of data within this frame. Now, if you print it, you'll get data in this format. That means we can create tables using data frame. And if you want, suppose you have a table of data, so how to see the summary of the data? For this, we have a function called summary and the name of the frame. So you can get, see, here we have data employee ID 1, 2, 3, 4, 5. And for the first column, the minimum value is 1, maximum is 5. Like that, a summary of the whole table you can get. If you want, you can add columns also. Suppose if we have a table and we want to add one more column in the table, so we can do that. And similarly, we can add rows also. That is, suppose we have collected few more rows or few more students data, so that we can add to the existing table using uh, using rbind function. And this is all, again shown here, use of row bind and column bind. Using column bind function, you can add columns, and using rbind function, you can add rows to the existing table. Now, how to take input from the user? So to take input from the user, we can use the readline or the scan function. Okay, so the read line is like this. These are sometimes very important because we want to take value from the user when the software is working. So read line, it takes the value one by one, and uh, suppose we are entering a value. So initially it is entered as a string, and if we want to convert it to an integer, so you can use the function as dot integer, as shown here, as dot integer, to convert an string to integer. And scan is another method for scanning data from the keyboard or reading a text file. So in research, we need to we may have several text files which we want to read. So that can be done using scan function. And we have also control statements here. We have different types of control statements in R, like if condition, else, if else, loops, and then nested loops. These are all supported by our programming language. And I think if I move to the programming, then I can show some programs over there. So I'll now go to RStudio and we'll write few code, which will, I think, be easy for the viewers. So I am now going to RStudio. And about R and RStudio. So R is a console, and RStudio is a tool which gives us the environment for writing program. And writing program in RStudio becomes very easy, and all the components will be available here. So let me give a brief description about the RStudio, how you can work. So this is RStudio, okay, and in this section we will write our program. Let me open a new file here, a new R script. So here I have opened a new R script. Here I can write my program, and when I execute a line of code, then the output comes in this section. and here we can get the help of various functions. The documentation is available here. Okay, the packages whatever installed in this are shown here. The plots, if we draw in the plot, it will be available here. So like that, it is full of various components. The most important part is this. Okay, suppose suppose we want to add two numbers. So for this we need to declare a variable. We say x is a variable, x, this is the assignment operator, so x is equals to suppose 10, and let me take another variable y, and y equals to say 20. So adding two numbers, so sum equals to x plus y. Okay, now how to execute? Keep your cursor on the line and click on the run button. Okay, keep your cursor here and click the run button. So the first line is executed, and you can see the output here. This is the R console. Here the output will come. Next, I run the second line. Click your cursor on the line and click the run button. The second line is executed. Now execute the third line. Now to print the value, print sum. Now execute the line. See, the result 30 is now displayed here. Okay, you can see the result here. Now if you want to execute all the lines together, because it is sometimes not convenient to execute the lines one by one, so let me execute all the lines once again, all together. So select all the lines and click the run button. Here you can see the console, we can see the output. First line executed, second line executed, third line executed, and then finally we're getting the sum of the two numbers 20 and 30. Now what is this? Square bracket and 1. This means that the variable sum has only one value. Okay, that's why that square bracket comes. Okay, so and say suppose you want to take some help, like say here I've used, if you want to take any help, and simply type help and say suppose I want to know about some package. Say the package is this is a package I know, and I want to know about this package. So click on any topic. If you just simply type here within help, within double quote, and click the run button. So R is now finding out that package, and you will get the complete detail about this particular, whatever you want to know. Complete detail will come in this window. You can read as long, I mean, everything about this. So this is the package offsets, and what it does, everything is given here. So like that, if you type any topic, like if you use here one function print, that you can copy and just put it here and click the run button. R will show you what is print and how it works. Okay, you can read it, and you can come to know about that function. Now let me do some basic programs. So this is what now another very important thing is working directory. So when we write our programs, so it is better to save all the files, all the programs into a particular folder. So for this we need to set the working directory, and for this the function is set working directory, SETWD. So this will make your set your current working directory, means whatever file you save will be saved in that particular location. So here I've created a folder, our presentation, in drive D, and in that I have created another folder program. So there I have stored all my programs. You can make your own folder and directory, and you can save your program in that. So first here, so I discussed about vector. So here I created a vector. Okay, creating a vector of numbers from 5 to 10. So all, I think these are all very simple and basic things, I'll skip this part and uh, I'll show you next. Okay, lists. Some of the, because list is a very important part. So let us create a list. Here I've written the code. To execute it, click the run button. Okay, so the list is created, and to see what is the content of the list, print it. So I created the list on these items. Let us see what. See, these are the result we got. So the list has how many items? 1, 2, 3, 4, 5 items. For this, we get the first square bracket represents the number of items. So we have the first item is red, second item is green. The third item has 3 elements. For this, in the third element has 3. So here we have these values. Like that, we have all the values here. Next, we can create list using a vector, and we can assign names also. We can assign names to the list elements. These are also very important. So for this, we create a name vector using the C function, and names of list. Here, names is the function, and within the bracket we give the name of the list. So we are assigning the name to each and every element of the list. So this list has, if I run it, this list has 2 items. One is a vector, and the second one is a matrix. Okay, and we are giving first quarter as the name of the first value of the list, and a matrix as the name of the second element, which is a matrix. So let me give the names. Assign name. Now if I print it, now if I print the list without assigning the name, it's already assigned. So let me print it. Here you can see the first name of the first item, second name of the second item. Okay, so this is about list, and you can do several other operations on the list. You can merge 2 lists. Here it is shown how to merge. Simply combine them within the C function, so it will merge the list. And another very important data structure is matrices. Now, how can you create a matrix? Using the matrix function. Now, if somebody want to know what is a matrix function, so for this, how does it work? How the code is written? For this, you can simply write here help, and within double quote you write matrix. Now I to know about the matrix function, because using matrix function I'm creating one matrix. How the code is written, how it works. Run, and see here the complete detail about the matrix function, in which package it belongs. It belongs to the base package, and the complete description, the parameters. These are the arguments we need to pass. Some of them are defaults, and the complete detail about the function is documented here. Even they have given example also. Here we have an example. Okay, so the developer of this package, they have given example also. You can simply copy this example and paste it into your R script and run it. So it's very easy and convenient to learn. Okay, so here what we're doing, creating a matrix of 4 rows, and the matrix elements are starting with from 3 to 14. So if I run this code and print it, so this is the matrix we created now. Okay, it's very simple to create a matrix, and this is the starting value. This is the ending value, and it is a row by row matrix. So 3, 4, 5, 6, 7, 8, 9, 10, like that, row wise matrix. You can make it a column wise matrix also. In that case, you have to make by row the value by row to false. That means you are not making it row wise, it will be automatically column wise. Let me execute it and print it. So now you can see we started with 3 and up to 14, but it is column wise 3, 4, 5, 6, 7, 8, 9, 10, like that, the column wise matrix. So it is up to you. You can make a row wise matrix or a column wise matrix. Next, you can define name also. So this is also very simple. You just create two brackets of rows name and column name and assign them in this parameter. Okay, here I am assigning the row name and column name. So now the matrix will have row names and column names also. Okay. Okay. Now accessing the matrix elements is very simple. Name of the matrix and you just mention the row number and the column number. I suppose I want to access the first row and third column. So for this, we can access like this. So I think I can skip this part. Matrix addition. Matrix addition is simple. Just put plus symbol within or the plus operator between the two matrices. We can get matrix addition, matrix subtraction, matrix multiplication and division. These are all uh, done in the same manner. But another thing is that matrix division. Now, if we have two matrices and if the division result is invalid, suppose you are dividing by 0, then in that case you will get invalid result. So here in R, they are not giving invalid result. They are simply writing it INF. That means the value cannot be represented. Factors also I discussed. So here they created a factor. I'll not show factor here because I already discussed it. And data frames. Data frames are very important because we want to data in tabular format. So for this, let me create a data frame here. So see the syntax is data.frame and within bracket you have to put all the items. So suppose this is one column, employee ID, second column employee name, third column is salary. So you can create the data columns in this manner, and if you execute this code, so a table is created and print the table. See, this is the table we created now. So you can create your own table as per your choice. Now we can perform various operations on this data frame. We can how to access the each element, how to add uh, rows in the existing table, how to add columns in the table. All those operations you can perform. And this is why data analysis is very much suitable using R programming language, because working in tabular data is very convenient. For example, here we have another. I'll show another here. See, so here this is a data frame created. Let me execute it. Okay. Next, summary of this data. Okay, for example, here we are creating employee ID 1 to 5. So and here we have salary. So what is the maximum salary? What is the average of the salary? So that we can get. Let me run it. Now this is the summary function will give you a complete detail about sorry, I'm getting call. Just a minute. So the summary function gives a complete detail about the data. Uh, Let me execute it once again. Yes. And now here we are. So this is the first column, employee ID. The minimum value was is 1 and maximum value is 5. You can have mean. The second column is a string, so length is 5. We have 5 characters for the 5 strings. Class is character, salary, and we have decimal value here. Minimum value is this, maximum value is this. We can have mean, median, all these values. A summary of the complete table we can have using a single function. Okay. Now here I have shown how to add rows, columns. So I will not show all these again. And C bind and R bind. These are very important because most of the time we need to add rows and add columns into our table because our table may increase or decrease in size. So for this we have functions C bind, is column bind. Suppose here we have 3 vectors, vector 1, city, state and zip. These are 3 vectors, and by combining these 3 vectors we can form a table. So for this we have a function cbind. Within this function we will mention the name of these variables, name of these vectors. So now these 3 vectors will make one table called address. So let me show you executing this. Run again. Okay, now if we combine it, okay, and print. See, earlier these were individual vectors, now they are combined into a table. So this is possible in R programming language. And for row bind we have R bind. So if we have 2 tables, we can combine these 2 tables into a single table. And here address, a new address is another table. If we run this, we'll get a single table here. No, there is an error. That means the second table is not created. Anyway, we can combine 2 tables. Next is taking input from the user. So here using the readline function we can take input. So here I'll show you now how to take value from the user. For this we have a readline. So when I run this readline, now the cursor is here. Here I have to put some value, say 100, and enter. So one value is taken from the keyboard. Next, I can convert it into an integer. So the string is converted to an integer. Now print it. So 100 is now is displayed as an integer. Okay, and if you want to read multiple lines, okay, several values from the keyboard, then we can put all these into a bracket, within brackets. Then we can enter number of values together. Say for example, if we run this code, then enter the first number. So I have entered 12. Second number say 23. Third number 44. Fourth number 6. Fifth number, so 4 numbers. So we entered 4 numbers here. And similarly, you can convert all these numbers, all these actually when we enter through keyboard, these are actually strings. So we sometimes need to convert them into integer. So for this we have a function as.integer, and the name of the variable. So it will convert that string into a integer. And if you want to add all these numbers, for this we have this. Using these plus operators, we can add all these numbers. So these are simple readline function, and we can use the scan function for scanning value from the from a file also. Okay, so scanning characters. You can execute this code. I'll share this code with you so that you can try all this code. And scanning a text file. Suppose we have a text file in Notepad or in uh, any text file we have. So here I have a text file called ABC, which I have saved in my uh, working directory. So if I run this code, okay, so there is some error, I think. Anyway, we can read any text file in this way using the scan function. Okay. Next is control statements in R. So we have all the control statements like if, else if, and all the basic programming constructs and control statements are available in R also. Here I have shown a very simple one. Suppose we have a variable x which is assigned a value 100. Now here I've written the statement like if x is greater than 10, then you print this message. Okay. Now to print, we have this function print and another function paste. So if I write it, execute it. Now we know that x is 100, and this function, this if condition is checking if x is greater than 10, then we will get this print message. See here x is greater than 10. That means this code is executed. There is one more. We have if and else. So suppose here I'm checking if x is greater than 10, then we have to print x is greater than 10, otherwise x is less than 10. Let us see what happens here. So x is greater than 10. That means because now the earlier value was 100. Now here we have 5. I have added 5, and now 5 is less than 10. Okay. Okay. Now for group functions. So all these are very simple things you can try on your own. So for example, here I'm creating a sequence of letters, a series of letters starting from 4 to 10. That means what will happen if we print x, we'll start with D. See, D, E, F, G, H, I, J, because I started from 4 and up to 10. That means if these are letters, then we have fourth letter means D. And if you want to print using for, you can print it like this. For I in x, that means x is what? 4 to 10. So I in x means the first value of x will be in I and print. Next, it will be repeated. Okay, and the second value will be printed, third value like that, and so on. All the values will be printed. And this is the while loop. I'll not show it. You can see it on your own. We have another option for repeating. It is called repeat. For looping, another option is repeat. And if you use repeat, you have to use a break. Otherwise, you will be in repeat forever. And next important thing is function. Okay, functions are very important part of R. It's not only in R. In any programming language, function is a very important language construct. So in R, we have two types of functions: built-in functions and or inbuilt functions and user-defined functions. So user-defined the built-in functions are like a sequence. So a sequence of characters or numbers will be created from the starting number and the end number, and mean, sum. These are all built-in functions. You can compute the sum of a number using this sum function. Now let us come to the important part, which is called the user-defined function. The syntax is keyword function, and the parameters if you want, all the parameters if you want, or even click, you can keep it empty also, and assign it to a variable. Okay, here this is the name of the variable which is created as a function, and the body of the function, or whatever activity you want to perform, that you put inside the function. Okay, so if I run this code, and what this function is doing here? Here is finding square of the numbers. So here I'll send one number. Uh, say if I send 5, then from 1 to 5, it will find the square of all the numbers, starting from 1 up to 5. So let us check what it does. The function is run. Now I have to call it. How to call it? So calling the function, the name of the function. Here the name of the function and the parameter, whatever value you want to pass. Here I am passing 6. So 6 will be assigned to this A, and the computation according to as per your choice will be performed, and the output will be displayed. Let's call the function. See, I actually passed the value 6, and 6 is taken in the variable A, and the function is printing the square of all the numbers starting from starting from 1. See, square of 1, square of 2, square of 3, square of 4 is 16, square of 5, and square of 6 is 36. So you can write your own function, and R supports a lot of plotting, charts, and graph. So R supports pie chart, bar chart, box plots, and so on, histogram, line graph, scatter plot. All these charts you can draw. These R supports a sophisticated set of functions and packages to draw different types of charts and graphs. Here I have shown a very simple one, a pie chart. Suppose we have a set of values. We run it, check it whether it is working or not. Okay, it is working. So here I am creating a pie chart using a set of values. This is the vector of values for which I am creating the pie chart. So run it, and these are the labels I have assigned. Suppose let me give a very small name like L for London, New York, and Singapore, and so Mumbai. Run it, and now for plotting pie chart we have the function pie. See here, you can see this output. So here see, plot shows you the chart, and you can draw your chart in. So here we have a package. This package I have already installed, and I can load it now. And let me draw another pie chart which is of 3-dimensional type. See, this is another pie chart which is even better than the previous one. So like that you can display sophisticated charts using various functions. Okay, so these are all the basic parts of R programming language. Now I'll go to another program where I'll show you how to build a model, like how to construct a model, and how to take a data set and predict the new class of the variables. So this R program, what it will do, it will take a data set. I'll take a data set. I created actually a data set called HIV. A small section of the data set I have taken here. So first I'll read the data set. Okay, so this is the data analysis part I'm talking about now. So first I'll read the data set, means I'll collect the data set and load it into my R program, and then as per the requirement of the package, I need to convert it into a decision table because I'm using a rough set based model for modeling, and for that I need to convert the data set into a decision table, and after that I'll perform some data cleaning operation like missing value completion and discretization and feature reduction. Missing value computation, because if my data has missing values, some data is not missing because it happens most of the time that users do not write all the data about themselves. So missing values are obvious. So missing value completion, how to complete the missing value, and there are various functions for missing value completions. I'll use one or two, and then feature reduction, because feature reduction is also very important part. In data sets, we may not all the features or attributes may not be important, so some of the features are redundant. So in that case, we would like to eliminate some of the features which are not important. So for that, feature reduction is important. There are lots of methods, and I use few here. And then I'll make partition of the dataset. I'll create one section of the dataset for building the model or training the model, and another part I'll keep for training and testing. Sorry, for testing. And then I'll create the model using the testing data, sorry, using the training data, and finally I'll show the prediction also, how it predicts for new data. So let us begin this data analysis part. Now, this model requires a package called RoughSets. So this is the this is the RoughSets package. Let me see whether it is already installed or not. Yes. So the RoughSets package is already installed. Then we need another. Now, next we need to. Now, let me show you one thing. I have created one table here, a data set. So this is the data set, a small section of the data set which I'll use for experimentation. This data set, I have named it as HIV data set, and I saved it as, let me show you where I saved it. Okay, I'll show you later. So this is the data set. Now it has 1, 2, 3, 4, 5, and 6 columns, means 6 attributes, and some of these attributes may be important or may not be important, and see, some values are missing. Okay, some values are missing, and we have totally 17 rows or 17 say persons. Okay, 17 persons data or 17 objects we have here, and 6 columns or 6 attributes. So this is my data set. Now, this data set is stored in this folder actually, because this is my working directory. So in drive D are I mean in this folder, yeah, I have created a folder program. In this folder, I saved my data set. The name of the dataset is hiv.csv. It's a comma separated value file. So to read this table into my program, I have this function read.csv. Okay, so this will read the file, and the file name is this. Data equals to true. That means I want to read the table along with its attribute names or column names, and separator equals to comma. That means it is a comma separated value file. So that's why I am giving here comma. So now suppose you want to know about this function. What is this read.csv file? So to know about this file, you can simply copy it and you can write help, name of the function, and execute it. See, here in this window, we have this read.table function. It belongs to a package called utils or utils, and a complete description about this function, how it works, and what all parameters or arguments we need to pass it. These are all, not all are compulsory, some are compulsory and some are optional. Okay, and the different versions of this CSV file, CSV2, and then these are all the different versions of this read function about all the arguments, and they have also given some examples how one can practice with the or how one can learn about this function. The example is also given here. Okay. Now let me execute this line and let me check if this table I can read in my program or not. So for this line is not required. And another thing is that here I just forgot to mention about these green lines. These are actually comments. In R, let me give a comment here. Suppose I want to write that this program is about modeling. Okay, so this is just to understand what the program is. So I will put it in a comment. How to put it in a comment? Keep your cursor at the beginning and let's give a hash. Now it has become a comment, and this will remain as a placeholder, and it will not be executed by R. Okay, so how? Now let me run this code because I want to read the file hiv.csv which is stored in my folder. Let me show you once again. So here, this is my file. Where it is? It is in D, R presentation for IT and program. This is the folder. This is the the CSV file. Now if you execute this line, so this line is executed and we have no error in this line. Now if I check if the table is available here or not, so in this variable the table is read and it is assigned in this variable. So I will select this, run it. See, the table is now available in my program. See, all the data is now read and now available in this program. Here you can check we have some missing value here. NA means not available. That means this data has missing values. So we will go for next. Next we'll go for missing value completion. Now as per requirement, we need to convert this data into a decision table. For this we have the function sf.as decision table. This is a function. This is the table which we just have read, and decision attribute equal to 6 means the sixth attribute is the decision attribute. See, this is the sixth attribute, which is the decision attribute. So for this I have mentioned, and we have five other attributes which are called conditional attributes, and these are mentioned here. Index.nominal, these are all nominal attributes from 1 to 5. Okay, next, missing value completion. For missing value completion, we have several functions. So one function is mb.concept close fit, and how it works and where it is available. To know this, you can simply copy it and using the help, where it is the help, yes, using the help function you can check about this function. So I'm checking what about the detail about this function, run it. Here we have the complete description about this file, who developed it, how it works, what are the arguments. Okay, all the details are given here. So the paper also, the author of the paper where it was published, and who wrote the R programs. Okay, and an example, these are all the complete detail is here. Okay, So after next, I need to complete convert it into a decision table. Now, if I print this table, because after missing value completion, I should not have the missing values. So let us see whether missing values can see. Earlier we had some NA values, means not available. Let me show. See, here we have one NA. Okay, before missing value, when we took or scanned the raw data set, we have NA values here, means missing values. But see here, we don't have NA value. The missing values are filled now. Okay, and now, now Now in the table we have 6 attributes. The sum of the attributes may not be important. So if those are not important, then we need to eliminate those. For this we have a feature reduction function. This is the feature reduction function fs.quickreduct.rst. Means fs means feature reduction. Quick reduct is an algorithm, and it is a rough set based algorithm. So the author of this function, those who wrote it, they named it accordingly. And in this function, we are giving the table, the process table. So it will compute the attributes which are important attributes, and the attributes which are not important will be eliminated. Let me execute it. It is executed. And if we want to see the attributes, see, age, living state or living status, residence. These are the 3 attributes which are important attributes or significant attributes. So this function fs.quickreduct, it has eliminated the remaining attributes and kept only these 3 as significant attributes. So one can apply different types of attribute reduction models or methods. Now after reduction, let us see the reduced table. See that that function, that quick reduct function, it has eliminated, discarded or eliminated some of the attributes, and after that the remaining table is like this. We have age, living status, and residence, and the decision column. So these are the remaining columns we have, because earlier in the table we had 1, 2, 3, 4, 5, 6 columns. Now after reduction we have 1, 2, 3, and 4 columns. These are the most important columns, and the remainings are just placeholders or maybe anomalies or something like that. Okay. After that, now we have the data. We have the data in this variable. Now I want to separate the data into training set and testing set. So for the function is create data partition. Okay, so this function takes several arguments. Here we have to put the name of the decision table and the name of the decision column. So here the dollar symbol means after the dollar symbol we can mention any attribute name. So here my decision column is hiv.sta. This is my decision column. So here I have mentioned, see here, I can put even other names also. See age, living style, residence, but I want to make the decision based on the decision column. So for this, I'll put hiv.sta. This is the decision column, and p equals to 0.70. That means we want to take 70% of the data as training data set, and remaining 30% will be kept for testing purpose. Okay. So this is the signature of the function. If you know about this function, you can even copy this and you can paste it here. See, we can see description about a particular function in this way. You can put it here, and click the enter button, you will get the complete detail. So create data partition. Okay, how it works, all the detail are given here. So once I execute this, no error, means it is executed successfully. Now the index are saved here. So using this, I am creating the training data set. If we check what is the training data set, this is the training data set, and the testing data set using remaining 30% of the data. See, we have only 3 rows for testing because the table has only 17 or around 20 20 rows. We have 30% of the data in this data for testing, and remember only 3 rows are there. Now building the model or constructing the model, for this the function is train, and name of the decision column, data is equals to training data. See, you are using training data set. This is our training data that we are mentioned here, and method equals to R part. So the model is built. Model is built. Now model is saved in this variable. Now predict. So we are using the testing data set for prediction. This model will predict for this testing data. Okay. This model will predict for the testing data, and for this the function is predict. Okay, so let us execute this line. And now to see the statistics about this, we can run this confusion matrix. The confusion matrix will keep the accuracy of the model. So here you see, this is the confusion matrix. Here you can see we had 2 rows with no values, and the model predicted correctly, and 1 row as yes. So accuracy of the model is 0.66. 95% CI is, this is also more maybe it depends on the data actually. The data, and here we have a very small segment of data, so the result will vary depending on the data set. So this is the statistics and the accuracy of the model. We can check here. Okay, now here in this model we used this particular function for missing value completion. Okay, now if you want, you can try with another method, another missing value completion model, and here we used quick detect algorithm for checking, for feature detection. Now I have created another model here. Where I just changed the missing value completion method. Here I use missing value completion, and the method is deletion classes. That means what it will do is it will delete the rows whose values are not there, and it will return the remaining part. So let me check if we apply this particular missing value method, then what is the result. And together with this, I have changed also another thing like the feature reduction method. Earlier we used the quick reduction model for feature reduction. And here I am using another method which is a heuristic method. Okay, this is a heuristic method. Now let me check what this heuristic method does, or if there is any change in the result. Just that means we are comparing these two models now. So again, all these packages are already installed, so I need not to install it. So let me run it once again. Now, if somebody want to see how many rows are there, for this the function is n row. So let me check how many rows are there. 16 rows. That means the table has 16 rows. And missing below completion using this method. So this method is actually, let me check the signature of this method. Uh, yes, coming. Missing below completion. We need to pass the decision table. We need to pass the type method. See, this is the signature of the function. Okay. What you have to give the data table and the method. So here we can pass several methods we have. These are the different methods we are given. The deletion class, most common value, uh, then most common value, global close fit, concept close fit. These are all different options. You can put any method from there, and you can. So as you change the different parameters, as you change the different methods, your result may vary. So the method which gives the best result may be chosen. So you can make comparative study also by changing the different methods. Let me run it. Missing value completion. Okay, I've already done this. Now the feature reduction using this heuristic method. Okay, so let me see what are the features taken by this method. It has taken only one feature. Okay, that means it has considered only age as the only age as the only significant attribute as per this model. So as you have seen in our earlier method uh, considered three attributes, but here it is considered only one attribute. So it actually depends on the data set also. Okay, if your data set is biased or uh, I mean it is up to the data set how you collect the data set and how good the data set is. Next is we need to convert it into a decision table again. And about this caret package, I'll tell you about it later. Okay, actually we need to install this package. So for this, now for installing package, we can download the package and run it in an offline mode, or if you are connected to the internet, then we can directly load it from internet. So let us see. I'm connected to the internet. So do you want to restart or no? I don't want to restart. Okay, fine. The package is installed and it is loaded. Now let me change the data size. That is, suppose earlier I used 70% of the data. Now I want to use, say, for example, 80% of the data for training and remaining 20 for testing. Now let us see if there is any change in the accuracy of the model. So since we have used 80% of the data for training, so remaining 20% is for testing. So here it is taken only 2 rows for testing, because of 20%, only 20%, and for testing it should have the remaining part. Yes, for training data we have the remaining all the rows. Okay. Now fit the model. Okay, predict, and let us see now the confusion matrix. So this is the confusion matrix, or this is the result. So this model gives accuracy of 0.5. So earlier the accuracy was 0.66, and now the accuracy has dropped down. That means the accuracy has gone down, and so we can. It is better to use the earlier model. So like that we can change. We can change different parameters. We can change different functions, and we can experiment accordingly. Okay, so this is all about this model, and this is all about my data analysis. And here actually I'd like to tell that I have used basically the rough set based models. Uh, we have several models, several functions for data analysis, but I have used here the rough set based models. So now I would like to ask Jantu sir if there is any question from the audience. Any question from the audience? Hello?
Yes, sir.
Hello?
Sir, yes, sir.
Hi, any question from the
Audience, please, you can ask question.
and these are the references if someone can follow or want to follow.
So I think, sir, I think they have understood everything, or maybe they are just attending the lecture.
Okay. One thing I would like to share here, Alok sir.
Yes, sir.
I would like to tell that I created one YouTube channel recently, where
Okay.
I have explained how to work in R. Just
Okay.
started the channel. So there I have shown how to install the R and RStudio, and few videos I have uploaded. So if they are interested, they can see that channel also, or they can contact with me for any kind of help and support.
Yeah, sir,
Sir,
can you send the link to the chat box or share the link to the chat box if it is available now?
Which one? That YouTube channel?
Yes, or whatever content you are talking about.
Okay, okay.
Or you can share with us. We will be sharing with all the participants.
Okay, let me share the name of the channel. Okay, so if
Okay,
they
okay, fine, sir.
open that channel, they'll find everything.
ठीक
Just I started it few days back, and I hope I'll continue uploading. If, see, this is the name of the channel, my name, and this is the name. They can type this and they can find it. Okay. Hello.
yes, sir, I'm here.
Okay, I have typed that name of the channel in the.
Sir, I think I have found that YouTube link. So I hope this is yours. In the
Yes.
chat box, I've given the link.
Okay.
Thank you, sir, for sharing.
Okay. Thank you very much. Thanks to all of you.
Thank you very much for giving us so much knowledge about our programming. So hope students will get benefit out of this. Thank you, sir. Thank you very much.
Thank you. Thank you. Shall I stop it?
Yes, sir.
Okay. Thank you.